Hello and welcome to Earthquake Tip number 21. My name is Shailesh Kumar Agarwal, Executive Director of BMTPC, and I'm going to present to you all about earthquakes, its concepts, terminologies, and how to construct buildings and structures to withstand earthquake forces through 32 earthquake tips, which are authored by Professor C.V.R. Murthy, mentored by Professor Sudhir Kumar Jain, and developed by IIT Kanpur in association with Building Materials and Technology Promotion Council, that is BMTPC. Through these tips, our aim is to spread right technical information in simple to comprehend language to our professionals who are in the field designing and constructing buildings and structures, especially our architects and engineers. But before we start, let's make a pledge that any new structure we design or build must be earthquake resistant. This earthquake tip number 21 will explain you why are ground story buildings vulnerable in earthquakes. RCC frame buildings are most common in urban India. Many such buildings constructed in recent times have a special feature as shown in this figure, that is, the ground story is left open for the purpose of parking. That means columns in the ground story do not have any infill or partition wall of brick masonry or RCC between them. Such buildings are called open ground story buildings or buildings on stilts. These buildings having only columns in ground story and both partition walls or infill walls and columns in the upper stories have mainly two distinct characteristics. First, it is relatively flexible in the ground story, meaning the relative horizontal displacement it undergoes in the ground story is much larger than what each of the story above it does. This flexible ground story is also called soft story. In engineering parlance, it means ground story has less stiffness than stories above it. Secondly, these open ground story buildings are relatively weak in the ground story. That is, the total horizontal force it can carry in the ground story is significantly smaller than what of each of the story above it can carry. Thus, the open ground story may be a weak story. In other words, it means ground story has less strength than the stories above it. Quite often, open ground buildings, which is the topic of this tip, is also called soft story buildings, even though their ground story may be soft or weak, as I explained you just now. Generally, the soft or weak story usually exists at the ground story level, but it could be at other story also. Having defined open ground story buildings, let us understand their earthquake behavior now. Open ground buildings has consistently shown poor performance during past earthquakes across the world. Let's take, for example, 1999 Turkey earthquake, 1999 Taiwan earthquake, and 2003 Algeria earthquake. A significant number of open ground story buildings collapsed. In India also, a large number of buildings with open ground stories to accommodate parking have been built in recent times. For instance, the city of Ahmedabad alone has about 25,000 five-story buildings and about 1,500 11-story buildings, and majority of them have open ground stories. The collapse of more than 100 reinforced cement concrete frame buildings with open ground story at Ahmedabad, which was 225 kilometers away from the epicenter during 2001 Bhuj Gujarat earthquake, has emphasized that open ground story buildings are extremely vulnerable under earthquake shaking. Despite of this fact, a large number of similarly designed and constructed buildings exist in various towns and cities uh, in India situated in moderate to severe seismic zones, that is zone 3, 4, and 5. Now let's look at this figure to understand the vulnerability of open ground stories. The presence of walls in upper stories make them much stiffer than the open ground story. That means the upper stories move almost together as a single block, and most of the horizontal displacement of the building occurs in the soft or open ground story itself. In common language, this type of building can be explained as building on chopsticks. See figure 2a. Such building swings back and forth like inverted pendulum during earthquake shaking. Now let's look at this figure 2b. When building swings the column in the open ground story, they are severely stressed, and if these columns are weak, means they do not have the required strength to resist these high stresses, or if they do not have high ductility to undergo large displacement, they may get severely damaged or even get collapsed. The same is shown in this figure 3a and b during 1971 San Fernando earthquake and 2001 Bhuj earthquake. The picture shows you severely damaged columns due to soft and weak story leading to collapse. Now let's understand the problem while designing RCC buildings through this figure 4. Open ground story buildings are inherently poor system with sudden drop in stiffness and strength in the ground story. In current practice, stiff masonry walls are neglected as shown in this figure 4a, and only the bare frames are considered in the design calculations as shown in figure 4b. That means the inverted pendulum effect is not captured when we are designing the RCC frame building. It calls for improved design strategies, which will be discussed now. The Indian Seismic Code, that is IS 1893 Part 1 2002, includes special design provisions related to soft stories, and that provision was included after the collapse of RCC buildings during 2001 Bhuj earthquake. There are two provisions which I will explain you one by one. Firstly, the code specifies when a building should be considered as a soft or weak story building. Having specified soft or weak story, the code specifies higher design forces for the soft story as compared to the rest of the structure. The code suggests that forces in the columns, beams, and shear walls under the action of seismic loads specified in the code may be obtained by considering the bare frame as shown in this figure. However, beam and columns in the open ground story are required to be designed for 2.5 times the forces obtained from this bare frame analysis. In essence, open ground story columns, beams need to be designed for 2.5 times more horizontal load than the stories above it. Designing buildings like this is one option. The best option would be to avoid such sudden and large decrease in the stiffness and strength in any story for all new RCC frame building we design or construct. It would be ideal to build walls either of masonry or RCC in the ground story, as you can see in this figure 5. Designers can avoid dangerous effects of flexible and weak ground story by ensuring that too many walls are not discontinued in the ground story. That means the drop in stiffness and strength in the ground story level is not abrupt due to absence of walls. As regards existing open ground story buildings, they need to be strengthened suitably so as to prevent them from collapsing during strong earthquake shaking. The most common method is to construct RCC walls on extreme outer side of the building. However, it is strongly advised that the owners should see the services of qualified structural engineers to increase seismic safety of these kind of buildings. This is all about earthquake tip number 21. You can download the tip from www.bmtpc.org. The next earthquake tip, that is tip number 22, will be on why are short columns more damaged during earthquakes. Thank you.